Okay, so hey guys, this video is basically me slowing down what I did in my last video, just so we can do a video under 10 minutes for the bare minimum of how we configure OSPF, Single Area OSPF on a router. Now, as you can see the topology here, you can pause the video at any moment to look at it. This is how I currently have it set up. There has been no OSPF configured as yet, but we do have IP addresses configured on each of the serial interfaces, and they are in a up state, and we can confirm on at least one of these routers that it is working by doing a show IP interface brief, and we can see that we have an IP address and the router interface is in an up state, and we can quickly do a show command, show running configuration, and we can see we have an IP address right there, and we should be good to go. So if we go back to R1 again, we do a ping from here. We're going to do a ping to say R2 10.0.0.2. it should go through. But if we do a ping for 20.0.0.1, which is R2 0.0/0 interface, it should not go through. So this is what the video is about. We're going to create OSPF so that we can actually have a success ping from R1 to our 20.0 network. Now essentially, if we go show IP route right now on R1, we can see that we have our 10.0 network and our 30.0 network, which are local networks that are connected directly to R1. Now the only route that's not in the routing table is 20.0 network, and effectively if we went over to R3 and did a show IP route, we can see that we only have the 30.0 network or a 20.0 network in our IP routing table, and we don't have our 10.0 network. That's because it's not directly connected to it is not in the network. 10.0 network is not connected, or R3 doesn't have a way to actually get to the 10.0 network, which is what OSPF is made for. And also effectively on R2, if you do a show IP route again, you can see that it's only learning the 10.0 network and the 20.0 network. So we need to configure OSPF to have adjacency between one of these routers so that R3 can learn of our 10.0 network, R1 can learn of our 20.0 network, and R2 can learn of our 30.0 network. So we're going to start on R1, and we're going to configure in global configuration mode router OSPF1 network, and we're going to add our local route 10.0.0.0. We're going to use a wildcard mask of 0.0.0.285 area 0. Now if you don't understand what the wildcard mask is, you're gonna have to do a bit of reading. I'm not going to go through that in this video because I'm trying to keep it as short as possible. Now we have our 10.0.0 network there. We're going to head over to R2, and we're going to add our global configuration mode, and we're going to go to router OSPF1 network and 0.0.0, and our wildcard mask and our area 0. Now after a couple seconds we should have our first OSPF adjacency on our 10.0 network. As we can see here, we have our first process, our adjacency. Now essentially, if we head back to R1 again and we do a show IP route, we can see that we are still not learning about our 20.0 network. So we're only learning about our 30.0 network and a 10.0. So what we have to do now is we're going to head back to R2, and we have to tell that router, say, hey, I want you to put our 20.0 network in our database table, and then I want you to send it to R1 so R1 is able to get to our 20.0 network. So if we do a show, if we do a network 20.0.0.0, and I'll use a wildcard mask of that 255 in our last octet, and we put our area 0, and then we can confirm if R1 is learning about that network, and we can also do show IP route, and as you can see, it's now learning about our 20.0.0 network. Now we're going to do the same for R2. We want R2 to learn about 30.0.0. So we're going to head over to R1, and we're going to say, hey, I want R2 to learn about my 30.0 network that I have here. So what I'm going to do is I'm going to configure my OSPF database so that it has 30.0 to advertise to R2. So how do I do that? I'm already in my config router mode, which is my OSPF config router mode, and I'm going to say network 30.0.0 area 0, and effectively if I head back over to R2 and I do a show IP route, it now knows about our 30.0 network. Now we can go to R3. R3 doesn't have any OSPF configurations yet, so if I do a show IP route command right now, as you can see, it knows nothing about a 10.0 network. If I head over to R1 and I do a show running config, as you can see, you're going to see all the configurations I made within our router OSPF and the networks that I added. If I head over to R3 and I did that same running config, you can see that there's no configuration that has been made on this router as yet. So what I'm going to have to do is now I'm going to have to go into global configuration mode, router OSPF 1. Now we can confirm that the OSPF 1 has just been configured by doing a do show run. You can see that we have a router OSPF 1 right there, and next we're going to add in our network. Now as I said before, once I do my do show IP route on here, you can see that our routing table still doesn't have our 10.0 network, but because we have already added in a local network for 10.0 and our 30.0 on R1, and the local networks for R2, which is 20.0 and 10.0 in their database, either of these local networks that I add to R3 should choose that route to learn our 10.0 network. So either, it doesn't matter which route I put in the table first, it should learn off the 10.0 network. So let's use our 30.0 network. So I'm going to say network 30.0.0 255 area 0, and we're going to have our OSPF adjacency being formed first, and then we're going to do show IP route, and there we go. It's learning about 10.0, and it's learning it via our 30.0.1, which is over here on R1 interface, via 0.0/0, which is our 0/0 interface here, local interface right here. And that's it. Thank you for watching, and I hope you look forward to see more videos from me.